Linear changes of scale and origin. The situation is exactly the same as it was for discrete random variables, in that changes of origin, adding a fixed number to the domain, affects only the expected value, but changes of scale, multiplying the domain by a fixed number, affects both expected values and the variance. This is illustrated in the diagrams below using a uniform continuous distribution, but the principle is the same for any type of distribution. So here we have a continuous uniform distribution, which we can see is non-zero between 2 and 8. Because of the symmetry, the expectation is 5, which is halfway between 2 and 8, and I've calculated the variance to be 3. If we just move this up by 3 units, the expectation has moved up by 3 units. But note the variance is the same because the spread of the distribution is still the same. Moving the distribution right or left changes the mean, but does not change the dispersion of the data. Hence the variance, and therefore the standard deviation, is unaffected. In this case, we've actually multiplied by 2. So we can see the lowest value here is 4, the expectation is 10, and the highest value is 16. This is now more dispersed. The rectangle is wider. We can see that the expectation has changed, and so has the variance. Remember, it was 3 before. Dilating the distribution, i.e. multiplying the data, affects both the expectation and the variance. The only time the expectation will remain the same under multiplication is if the expectation was originally 0. Suppose we have a continuous random variable x and a continuous random variable y defined as y is equal to ax plus b. So that's a linear transformation. Then the expectation of y is equal to a times the expectation of x plus b. So the expectation is affected both by the multiplication and by the addition. However, var y is equal to a squared var x. The b makes no difference to the variance because it doesn't affect the spread of the data. Note that this is squared because we know the variance is a squared quantity. The standard deviation would be a times the standard deviation of x.